Good evening, friends. Welcome back to another session on logistic analytics. In today's session, we will be discussing on supervised learning technique. And in supervised learning technique, we will be discussing on simple linear regression model. Right? We'll also do hands-on. Simple linear regression is a type of regression that talks about the relationship between a dependent variable and a single independent variable, right? And the relationship is shown in this model. Now, what will be your variables here? That is key factors. When you talk about key factors, you have the dependent variables, right? It is talking about the relationship between your dependent variable and independent variable, right? Your dependent variables are your output, or we call it as responses, results. When it comes to independent variables, that is your features, we call them independent variable regressors. Okay. And we can also talk about regression problems, right? And you will have regression problems usually in continuous or the unbounded variable. However, your independent variables can be continuous, discrete, and even categorical, like you could have the airlines, right? The ports, locations. Aircrafts, basically talking about the brand, right? We can also consider the locations as well, right? And when it comes to forecasting, it talks about the profit, right? The invested amount, or the money that was made in the industry, in this particular industry, logistic industry. Right? We will be able to look at the correlation between these two variables in simple linear regression. And with that help, we can build a model which is a best fit. Okay, and also representing these two variables, that is the relationship between these two variables. Yes, are you by now I'm assuming you're all familiar with data pre-processing, right? Now there are certain points. How to calculate simple linear regression? Okay, how do you perform these calculations, right? You have these, relationships between, let me put this, see, you're talking about need for your simple linear regression, right? So it is helping in setting your new predictor. And it will help you in these industries as well, right? Let me add logistics industry, supply chain as well, right? Supply chain is something a bit familiar. I'm like similar, right? It will help you understand the relationship between your X and Y, right? And if you are drawing a line diagonally from the bottom left to the all the way top, it is generally describing the data. It is describing the relationship between the data, right? This is one good example when it comes to linear regression. Okay, so it is better to have less data. Okay, I'm not trying to generalize this statement. Okay, so what we do is, when we have a single variable, that is X, and we want to use linear regression. Okay, for example, let me have x1, x2, x3. Right? If I have multiple columns, features, this will be multiple linear regression. Right? And it is all different when it comes to multiple linear regression and simple linear regression. Okay. So that is, when you look at formula, you can say y is equal to beta naught plus into this into x. Right here, your is equal to mean. Y variable. Okay, minus mean of mean of y into mean of x. Now, if you were to estimate the slope, you do 1 by n into a total sum of x. And how do you do the average? Mean of x and mean of y. So here will be your intercept. Right? It will help you do a prediction. Right? This is called the trend line for your series data, two series data. Right? This is your what we call as estimated regression line. And this is the actual response. Right? And this is the predicted response. Now, how do you calculate the estimated error? If we look at this, you're saying RMSC is equal to square root of square root into sum divided by 2, or yeah, square root of sum of minus to the power of 2 whole divided by n. And when you calculate that with your data set, you will get your answer. You'll get your RMSC value. Right? We also talked about how it is able, your machine learning algorithm is able to predict the future outcomes. For example, if there will be a delay or cancellation of the shipment, right? Will the aircraft is on time or not? So these are certain predictions your model can recognize. So it can predict. Okay, we also look at the mean squared root, not just RMSE, squared root, that is squared error, and also the minima of these large data sets. So once you have your scores based on your train and test, you get to see the relationship between these two variables. Right, and it is recommended that we should be trying the regression model, that is linear regression model, when it comes to one of the machine learning techniques, when it comes to predict or come up with a correlation between two variables. Okay, we'll also do hands-on on the code as well as the data set. Right, what are few libraries that we can look at? So we deal with NumPy, right? It is a scientific Python package, right? It is a fundamental Python package that allows us to perform and look at the multi-dimensional arrays as well as your mathematical computation, right? So your numerical computation will also be able to do that, right? And scikit-learn is a package for your machine learning. We'll also be using NumPy and other packages. We will look at them as well. Okay, once you have your packages installed and imported, so what we do, we do a data pre-processing. Right? That will help us reduce the dimensionality and imply the regression. Right? Of course, these libraries are open source. It is said that your linear regression model, right, your machine learning model is simpler yet robust in its performance. Okay, it gives you a better understanding through visualization. right? Let us try and look at the model. I will be launching Spider. All right. So here I'm importing these libraries. Pandas is for your data manipulation as well as NumPy. I'll start off with these, and I'm defining a variable called frequency, right? And I'm reading the file, which is in Excel format. And then I'm passing the location, the path where I have my data set in my local machine. Let me paste. I simply look at the path and then I have to paste it. I'm replacing my backward slash with forward slash. And then I would like to run this, read the data basically. So now here I have the data. This is my data frame. This is how it looks. So I have 17,565 rows and 6 columns, right? I have departure airport. Are you able to see this? Right, I have departure airport, origin country, arrival airport, destination country. This is aircraft name of the aircraft, and also we have frequency. Okay. Now I'm writing frequency dot describe. So we are looking at so we have count, mean, standard deviation, right? The frequency as well. And then if we were to look at the data types, right? So we have these data types in categorical format. Now, I would like to convert these particular columns, which are in categorical. I would like to convert these into numerical data type. Okay, so I am doing a label encoding. Okay. So basically, I'm converting these categorical data into numerics. And what are the columns that I am doing it? I'm doing it for departure airport, origin airport, arrival as well as the destination country and aircraft name. And also the label encoding. For label encoder, I'm importing these libraries. I'm saying from sklearn import preprocessing. Okay. And this is how you deal with the labels. Okay, we are doing a label encoding to see how it is being done. So here I'm transforming these to categorical to numeric. How do I know that? How can I look at that? You can run multiple times. You can run the code multiple times. See. See, you have the data here. It has been converted to numeric format. Same with origin of the country. Arrival. I'm just double checking it. That's it. Right. So these are all converted into your numeric format. Now, let me have a look at the graphical visualization. Let us look at graphical representation. I'm importing a library called matplotlib.pyplot alias APLT. Okay, I would like to look at this. I'm saying PLT dot bar height is equal to frequency dot departure airport. Okay, we are looking at one column, that is frequency. Since Spider is a standalone application, it is taking more than the usual time. Now let us look at what we can do is, you can hold on. It's still loading. So this is how your bar plot. Are you able to see this? Yes, this should be quite legible. Okay, so each data point and its frequency, you can see here. Okay, and this, for this particular column, this row, the frequency is at around somewhere close to 550. Okay, same with these. Now this is close to 600. We are looking at the frequency frame. And since we have a lot of rows, that is the reason it is all, close to one another. Okay, let me close this up. Let us look at histogram. This is here. It is talking about the skewness. Right? Here you get to see if it is left skewed or right skewed. Okay. Again, because of the size of the data. And in this particular model, the data looks this way. If you have a different model, if you are building a different model with a different data set, it might be different. Now let us look at box plot. Box plot, with the help of box plot, you will be able to look at if there are any outliers in your data frame. And by looking at box plot, we conclude that there are no outliers in our data set. But if there are any outliers, what is that you do? You treat the outlier treatment. right? We looked at the departure airport. Now we look at the arrival airport. Okay, our x variables and that is sorry, x variable and y variable. I like spider, usually using spider, but for some reason it's slow. Yes, it looks perfect. See, there is a minute difference. Earlier, the frequency was around 550, right? If you look at this graph, box plot, frequency is close to 450. Right? Similarly with others also, you can identify that. So this will give you a visual representation, that is graphical representation of these data. It makes more easy to make decisions. Take proper business decision. Yes, we were talking about bar graph, right? Let us look at histogram. See, are you able to see the difference? Again, skewness can be measured if it is left skewed or right skewed. And in arrival location, there are no outliers. Now let us look at correlation. I'm saying NP dot COR coefficient, and then I'm looking at the arrival of frequency at arrival and the frequency at departure. Okay, so this is how my graph looks. And if I were to look at the covariance output, and if I call covariant underscore output, that is giving me 1372.681 is a covariant. And if I do frequency dot covariance, let us look at frequency of covariance. So here is my simple linear regression model. Okay, I'm importing stats model dot formula dot API. Let's run this. So now if I look at the prediction, this is for my arrival airport. And the regression line as well. And if I were to calculate the error, I'm also calculating mean squared error as well as RMS. Okay, we are building a model on our transformed data. You see the frequency here in scatter plot. So different graphical visualization we get to see. This is our transformed data. If we were to predict the model, as well as the regression line, we'll do a look at the plotting. Based on that, we will also calculate the error. This is your exponential transformation based on the scatter plot. So we are trying different models and we are trying to showcase which model is giving us the best result. Okay, we have done a manual EDA. And out of all these models that we have tried, here we are choosing the best fit. And that is based on the RMSE value. Right? We also train the data as well as test the data. We have train data. I'm sorry about that. We have train data, test data, as well as split. And now if you want to predict the test data, you do test underscore predict is equal to, you're saying final model dot predict. And once you have predicted on test data, you evaluate test data. Right? Now, once you are done with the test data, predicting and evaluating, we will look at predicting the train data. And we are evaluating on train data here. Right, you say train underscore RMSC is equal to NP dot square root. Okay. Yes, your spider might be a little late in responding, but that is okay. This works both in your, Google Colab as well as Jupyter Notebook. You can try either of those two. Right. Right. And based on this, so here we are trying multiple models and we are going with the best fit model. Okay. And we are building this manually. All right. And we have chosen the model based on the RMSD value here in this particular case. Okay. All right, friends, we will stop our discussion here for the day and we will continue in our next session. Okay. Thank you all for joining. You all have a good day.